Alright guys, first thing we're going to talk about today is some new vocab. So our first vocab word is radian. A radian is a unit of angle measure based on arc length. So a radian is just a different way of expressing how we measure angles. Typically you guys are using degrees. And while degrees are, easy to use, the degrees are probably easier to do with mental math, there are certain applications that radians are more appropriate. For example, in some higher level math classes, like pre-calculus, calculus, etc., certain applications only are expressed in radians. And it has to go this deal with arc length. Because it's a unit of angle measure based on arc length, it actually brings the concept of distance into angle measurement. So it's more of a unit of distance as well. So this has some interesting applications for using radians as opposed to degrees. Another kind of important part we want to remember is that the circumference formula is 2 pi r, where r is just represents the radius, right? So that's how we find the circumference. That's the distance around a circle, 2 pi r. Well, look right below. See that 2 pi part? Well, 360 degrees is equal to 2 pi. So the distance around a circle is 360 degrees. In terms of radians, the distance around a circle is 2 pi radians. So radians is an angle measurement, like a classification of an angle measurement. Whereas degrees is something you're used to, radians is another method. This is kind of our conversion rate. 360 equals 2 pi. Another way of writing that is down below. So this is how we're going to convert between radians and degrees and radians. So if we were given something in degrees and we wanted to convert to radians, we would multiply the number of degrees by pi over 180. That would leave our answer in radians. If we wanted to convert from radians to degrees, then we'd multiply the number of radians by 180 degrees over pi radians. That would leave our answer in degrees. I have some examples down below to practice. So all we're doing is we're making a conversion, right? And you guys have done conversions your whole math career, right? We've converted inches to feet, quarts to gallons, all kinds of different things. So it's just a different type of conversion. I'm converting degrees to radians. So degrees to radians. My notes are right here. Use your notes. You guys have these videos and your notes always available to you. Please use your notes. Multiply the number of degrees by pi over 180. Okay, times pi over 180. Notice the degrees, right? We can cross simplify. How many times does 45 go into 180? 45 goes into 180 4 times. So we can rewrite this by simplifying that 45 goes into 180 4 times. Rewrite this as negative 1 over 1 pi over 4. Now we're going to multiply straight across. Negative 1 times pi is just negative pi. 1 times 4 is 4. Therefore, negative 45 degrees converts to be negative pi over 4 radians. Notice your radian answers always has pi in them. Degrees answers do not have pi in your answers. Let's do reverse this time. We're going to convert from radians to degrees. The way we converted from radians to degrees is up here. Radians to degrees. We multiply by 180 over pi. So let's check that out. 5 pi over 3 times 180 over pi. Remember we said degree answers won't have pi. Well, the pi's can kind of cancel each other out because they're across from each other. So already I'm not going to have pi in my answer. 3 also is a factor of 180. 3 goes into 180 60 times. Now we're going to multiply straight across. 5 times 60 is 300. 1 times, this is a 1 over here, is just 1. So it's 300 over 1, or simply 300 degrees. 5 pi over 3 radians converts to be 300 degrees. Again, we're just using this conversion factor. So you're going to want to keep looking back at these conversion factors. Convert 80 degrees to radians. 80 degrees, convert to radians, times pi over 180. 80 is a factor of 180, or rather, they're not a factor of it, but they share common factors. 10 goes into each one of them, so we can cancel out a 0. I see I have 8 and 18. Well, 8 also shares factors with 18. Maybe I can factor out a 2. Now when we do our multiplying, 4 times pi is 4 pi. 1 times 9 is 9. My conversion is 80 degrees is equal to 4 pi over 9 radians. 2 pi over 9 radians. We want to convert this to degrees. Convert radians to degrees. We're going to multiply 180 over pi. 2 pi over 9 multiply by 180 over pi. Notice once again that the pi's cancel out whenever I need to go back to degrees. Degrees will never have pi in our answer. Now I can simplify again. 9 is a factor of 180. 9 goes into 180 20 times. Now we'll multiply straight across. 2 times 20 is 40 degrees. 2 pi over 9 radians converts to be 40 degrees. Now, last week we had talked about special right triangles. 30 degrees, 45 degrees, and 60 degrees show up in our special right triangles. We could have this is a 45, 45, 90 triangle. And over here, put that right angle in there as well, that's the 90. And over here, we have a 30, 60, 90 triangle. So now we want to be able to rewrite our special right triangle rules, but in terms of radians. So let's rewrite our special right triangle rules in terms of radians. What's 30 degrees in radian form? Well, 30 degrees in radians, 30 times pi over 180. This is how we convert to radians. 30 goes into 180 6 times. Therefore, 30 degrees is pi over 6 radians. So we said, what is the sine of pi over 6? That's really like saying the sine of 30 degrees. The sine is the opposite over the hypotenuse. The sine of pi over 6 is 1 over 2. The cosine of pi over 6 is the adjacent over the hypotenuse. For people that don't recall last week's video, we are referring to that SOHCAHTOA trick, or sine, cosine, tangent. The cosine is your adjacent over hypotenuse. Adjacent is radical 3 over 2 hypotenuse. Last, the tangent of pi over 6. Tangent of pi over 6 is the opposite over the adjacent, which is 1 over radical 3. However, we don't leave our answer as 1 over radical 3 because we never leave our answer with a radical in the denominator. So we would rewrite this to be radical 3 over 3. If you're not sure why we're rewriting it this way, go back to Miss Furman's video from last week. She did a very good job in explaining how to rationalize the denominator. You can see these trigonometric ratios are the same as last week's video. The only difference is, instead of saying the tangent of 30 degrees, now we wrote the tangent of pi over 6 radians. So we're expressing angle measurements in terms of radians and degrees. And this is going to be a very common theme for this section of our notes and practice problems. using degrees and radian measures. To convert 45 degrees, I'm going to circle this previous answer. We do 45 degrees times pi over 180. Simplifying, this would become 45 goes into 180 4 times, pi over 4 radians. I'm circling these answers because these are some common angle measurements you're going to see a lot. 30 degrees, 45 degrees, 60 degrees are used very frequently in trigonometric ratios, geometry problems, even in pre-calculus and calculus. You see these angle measurements a lot, or multiples of these angles. The reason why is it's very easy to memorize these special right triangles and use those special right triangles to answer all sorts of questions. 60 degrees, that's our last one we got to convert to radians. We're going to multiply by pi over 180. 60 goes into 180 3 times. So 60 degrees is equal to pi over 3 radians. All right? Again, 30, 60, 45, these are special angles that we're going to know. So you're going to see pi over 6, pi over 4, pi over 3 radians show up very frequently. Again, or multiples of those angles. Here are special right triangles. We can rewrite our special right triangles with radian measurements. So we could write 45 degrees as pi over 4. We can write 30 degrees as pi over 6. We can write 60 degrees as pi over 3. You're going to see these angle measurements and these special right triangles a lot throughout this unit. Right? You're going to use this information to help you solve today's practice problems.